Okay, good morning and welcome to my talk about Silverblue with disk encryptions and with a spicy side story, the main story how I almost lost everything but gained much wisdom, and the side story about Bmaptool and Ddrescue and why you shouldn't be using DD. That's about me. I joined CodeSync last year and working on embedded Linux stuff mainly. And using Fedora Silverblue as a daily driver since I think about 5 years. Okay, so what happened? You know, just casual morning, kind of hacking around with some embedded stuff. Have this fancy RADXA ROCK 5B board, which can boot from all kinds of stuff, so you're imaging things back and forth to various devices, USB and NVMe. Wow, embedded has NVMe now as well, not fancy stuff. Anyway, somehow, not fully awake yet, I typed sudo dd offdef NVMe, but in the wrong terminal. Which, well, yeah. And at first I thought, well, not a big deal. That image, it's an embedded image, just like 8 gigabytes. No big deal, my SSD is like 2 terabytes. I mean, who cares about 8 gigabytes? But yeah. I hope you guys learn something today, because if you're not prepared, that can be basically the end of your 2 terabytes. That's what this is basically. So I mean, if you look at the default kind of setup, if you install Silverblue, or I guess any other distro usually does it similar, not? You have some kind of some boot partition stuff, EFI, probably another partition boot where you have the kernel and things like that. In Silverblue, this is special as you basically have your deployments there, not? So you can have multiple things. You can have multiple kernels, and you can go back and forth and stuff like that, not? And all atomic. But yeah, so what happens? Basically, with 8 gigabytes, you overwrite this whole boot chain, and then you have like your system partition, which nowadays you have it encrypted, of course, because who knows? If somebody steals your notebook, you don't want all your confidential data to be gone, so it has a Lux partition there, and of course the first part of that also got wiped. But let's first look, because I have the journal of this really nice event, not? So it's kind of funny to look at that. I mean, I did a lot of yoga and stuff, so I'm over it now, so I can talk about it now, it's fine. So basically you can see it was October 2, 9:30. I just docked in, because that I had some USB messages, so then yeah, I was playing with this image stuff, like I said, so I actually even was also looking at some of these disk images, so I did some LO setup stuff just to look at these disk images of these embedded devices and kind of poke those. I mounted some loop mounted some stuff, things like that, and then I plugged in a USB stick, not because I wanted to. Basically, that was what I wanted to write to, not. So, very nice. And then, I don't know whether you also do this dirty trick stuff. I usually kind of hate when you have all this convoluted sudo stuff and then it asks you about the password in the middle there, so I just kind of prime my terminal to be a sudo terminal by just doing like sudo ls or something. I don't know, maybe not a good idea, but and then just kind of copy-paste it casually on command. But yeah, I was in the wrong terminal, of course, yeah. And then it's kind of cool. You can see that, yeah, udisk daemon immediately kind of, woo, something is happening, not noticed it pretty quick. But yeah. And then I even flushed the stuff. But I actually flushed a USB stick, which doesn't really do much because I didn't write that one, but yeah. What else is going on? Yeah, I mean, I removed the USB stick, and of course I tried it then on the embedded device, but somehow wasn't much luck. I mean, yeah, didn't boot. I thought, wow, stupid thing. Bad morning, not. So I actually retried it again. Very good. Didn't kind of, I don't know, blurry vision or something. Flush it again. Very good. Removed it again. And then I kind of got mad about the USB stick. You know, USB sticks, they just kind of suck, not? I don't know. I had so many go bad. Meanwhile, if you're like, I don't know, 30 years in the career, I even collect them. I don't know. What do you do with broken USB sticks?
Put them back in the drawer.
Anyway, yeah. So I plugged in another one. Could be SanDisk has a bad day. Try Kingston. Okay, but then, okay, wait a minute. I started to look into DMESC. You never know. Something doesn't feel right, not? Okay, undock it. Let's look further. I looked at my partitions and kind of started to realize what happened, not? And then, actually it's kind of funny, not? It survived like half an hour with that, but then the boot partition started to go bad, not? And then, yeah, that's just kind of life, not? In the background it's even doing some updates, of course. You want to be up to date. Doesn't really help in that case, because that partition is not too healthy anymore. So, yeah, a few minutes later the system partition also kind of goes bad. And, yeah, I/O error. And the kernel is doing the right thing, not remounting it read-only. And that's the end of the journal, because you don't write any journals to the read-only drives. Yeah. That's basically it. So how about this disk encryption now? But imagine at that point in time I thought, well, I still thought, well, not a big deal. 8 GB of 2 TB. I will just reboot with some live thing, not, and just kind of get it going again. I mean, not a big deal. Just a casual morning of some Linux guy, not that basically you hack around a little bit, no problem. But then, yeah, during installation it sounds really easy, not? You check this encrypt system checkbox, automatic partitioning anyway, lazy, not? I mean, hopefully all the other guys working on it have chosen good defaults for me, not? However, so how does it work? Block device encryption, not? It transparently encrypts, decrypts all your stuff. And so the underlying block device only sees encrypted data. So if you have that data, you cannot do anything with it, not? And you need a passphrase to mount it. And of course it's nice if it gets stolen, nobody can decrypt it without the passphrase. And now it's basically decrypt looks, not Linux Unified Key Setup. It's basically a specification for this whole encryption things, and it specifies the on-disk format of this, and also has the passphrase, key management policy, all this kind of stuff. And underneath it uses the kernel device mapper, so the subsystem via Decrypt, and basically handles the low-level stuff, not. And for user-level operations, there are the crypt setup utilities. And yeah, I guess you guys, whoever uses it as well at system startup, you get kind of presented with a passphrase prompt, you enter that, and then it's continuous regular boot. Looks, it encrypts the entire block device, and it protects the contents, so even if you would remove the storage device or have a removable storage device, you can use it on there. And basically it doesn't care about what data you then put, not it transparently just encrypts it and decrypts it again. So you can also use it for swap. That way, not even something can leak if you kind of suspend it and have a swap partition or stuff like that. Even that is then also encrypted. You can also use it for special data, like if you have databases that use their own, special format, block device, whatever, because it transparently encrypts it underneath. And device mapper, the good thing about that, it's a well-proven, tested subsystem, not because also, for example, LVM uses it. And it also has passphrase strengthening and some protection against dictionary attacks and stuff like that. And you can have multiple key slots. So, yeah, you can have like backup keys or stuff like that. However, it's not suited that you would kind of use that for multiple users or something like that to have all their keys. Not it doesn't really. Usually, you only have 8 slots of this key passphrase stuff. Also, not suited for kind of file level encryption things. There are other tools for that. The tooling, crypt setup, and usually the way during boot and stuff it's handled, it's with systemd crypt setup. So you don't really have to do anything, it's all transparent, and integrated into distros. So Fedora Silverblue, lessons learned. Basically, yeah, if you wipe your looks header, you're basically gone. So you cannot really decrypt. I mean, yeah, I could wait. I still have a backup of that 2 terabyte disk. Not maybe with some quantum computer you could decrypt it in the future. Not who knows? But if you don't have the header, it's basically just really random encrypted data. You cannot do anything. Not. That's what I learned. And then one thing that I now did and recommend to do anyway, the default boot partition 1 gigabyte is anyway way too small if you want to keep multiple deployments in Silverblue. Not. I usually keep some deployments of every kernel version, so if I want to try something or things like that, I can easily go back. Not. And then over the years you have Fedora version updates, and you can just really go back and easily boot again into whatever older version. Not. So this 1 gigabyte default just limits the amount of deployments, and also in such a disaster case, it is rather small, so you overwrite the whole thing and into your system partition. So I now did a bigger one. I suggest using at least like 16 gigabytes. And then, of course, the most important thing is back up your looks header. Because, I mean, honestly, if that one goes corrupt or whatever, you saw it, without that, you cannot decrypt your thing. It's just gone, basically. There is no way to decrypt your disk without this header. And it would be only 16 megabyte in size. Not too big, but it's crucial. And of course, also back up your keys. Usually one also does that, and I did and even printed them, but that they're useless without the header. You can hang it up on the wall. Together with the 2 terabyte SSD. Now it's too expensive. I'm still using that one. It didn't hurt the SSD basically, not? It doesn't care. Using it as a daily driver, Fedora Silverblue, of course, you get used to, you just do your things with Flatpak or in a toolbox, or I think it got renamed to Tool BX. Just relax, usually it works, not with Flatpak. If you have some weirdo issues, usually Flat Seal might help. So you can open some things like, at times I have some printing doesn't work or things like that. Just hack around with Flat Seal, usually that helps. And then of course as an embedded guy you have some kind of system tools that, yeah, basically one problem is if you're in a toolbox, of course, it's this rootless stuff, not so you cannot do real root things on your real system from a toolbox. So there I'm just usually lazy and copy the tool out and just run it like that. Not. I will also show that later in the Bmap usage. That kind of works fine because you could also layer stuff, but I usually avoid doing that too much. I mean, you could RPM OS3 layer it, not you could can also install some tools there, but it's just, I don't know, it's not worth it for me. And for Python stuff, you anyway just use a VM, not. And then, that's another thing, I don't know. My eyes get worse, so, and I think it still doesn't default to this fractional scaling stuff, but that's one of the commands I usually enable this, and then you can scale it whatever you like, not. And with Flatpak, I usually use upstream FlatHub. I don't know why Fedora does their own thing with Flatpak, or why does everybody have to do that? Just use, I don't get it. Why would you use that? Anyway. So I just Flatpak remove everything when I do a new install and delete this Fedora thing feed and just install it from FlatHub. I don't know. Then of course Silverblue, libOS3, previously just called OS3. It's really nice, not? It's from Project Atomic for those guys that still remember, not? I also run it on the server, by the way. There it's called nowadays Core OS. Works fine. So you can look at the status of your deployments. You can look at the OS3 log. You can deploy one of the, available things, and you can look at the remote refs, and you can basically rebase. So that's how you basically change between Fedora versions. You just do a RPMOS3 rebase, not? And you reboot, and you can just switch between Fedora versions like a snap, not? And then you can even pin them. That way they don't get basically removed with a further future update, not? So you can pin and unpin deployments. And yeah, it's basically Git for operating system binaries, not. So you have versioned updates for Linux-based operating systems. One thing, of course, I'm also a kind of a network guy, playing with OpenWRT a lot. And one thing, you install Wireshark with Flatpak, and then you're wondering, but how do you now do that? Because it doesn't show you any interfaces or anything. Turns out it works fairly easily. You just separately do your TCP dump magic and then pipe it into your Flatpak Wireshark. And that, yeah, you just need to have a cheat sheet how you do that, of course, but that works beautifully. And yeah, you basically missed my USB talk if you're wondering how that works. Not. I showed it there live with an embedded system. No? And another tool, for example, Meld, I use a lot. You review code, you diff it, and you can also do that. You just do an alias. That basically runs the Flatpak stuff underneath. Yeah, watch my other talks with some of these tips, not? And this is the bonus track. How you do, for example, DHCP, TFTP for embedded use on a Silverblue, where you don't really, want to kind of layer some other tools or whatever not. It's actually already there. You have network manager. Usually I use some intelligent switch with VLANs, not? And you just have your developer network, not VLAN DevNet. You create that. You masquerade that. You add in the firewall, you open DHCP, DNS, FTP, whatever other stuff. And then you just do the method share. That means it will share that VLAN to your regular, so it shares your regular internet connection. So the embedded device even also can get to the internet. And then for TFTP boot, you create some folder where you put your stuff, make sure you have the right access stuff as well. And then basically with network manager, DNS mask is integrated, not, and you can just have this conf file, and you just in there you say enable TFTP, and then it also does TFTP, and you can give it that folder that you have prepared, and you can say what file it by default should serve, and you can even give, if you know the MAC address of your embedded devices, you can give them their IP addresses and basically do that statically. Not. Works very well. Okay, let's have a look at the side story. Bmaptool. Pretty cool. It's a generic tool. It basically creates block maps for a file, and then it allows you copying files using that block map. And of course that is then much faster and more reliable for large files or such raw system image files that you encounter in embedded use. Originally it was created for the Tizen IVI project, and it's written in Python. Of course, faster depends on various factors, not the write speed, image size, and of course how full an image is, the so-called sparseness. But in general it proves around 5 to 7 times faster. How about the integrity usability of it? It verifies data while flashing, and it also notices possible corruption immediately. And the usability, it reads directly, also allows directly reading from remote servers, so you wouldn't have to copy them locally, the images. And user data is protected because it kind of protects you from such stupidity that I did, because it wrong block device names or things like that. It checks whether a device is mounted and would then, warn you. Do you really want to do that or not? Because usually you don't. That's how you can use it. Like I said, I just usually copy it out from a regular thing. I mean, from a toolbox where I installed it. And then you can easily also use that from your regular not toolbox thing, where you can run as root, which you have to if you want to access a block device, not. And you can just specify the Python path and run it like that. And it has basically two commands: the create, to basically take such a raw image and investigate it and find out what its sparseness is, not, and it generates the block map. And the copy is then to actually write, once you have the image and the block map, write it to a block device. From concept point of view, it's the sparse files. So file system maps blocks of file data to disk sectors, not. And usually there is a disk index that points to these mapped blocks. And of course, if you have free area that is not mapped yet, you basically have holes not in your files. And they don't occupy space. And the block map is just an XML file that contains a list of this mapped area, and the raw images, I mean, if you have, for embedded systems, such disk images, they hardly ever are fully mapped, not. That usually you might have a much bigger storage device than the actual data. Not? And sparse files, so they help save disk space. And when you read from such a file, it returns zeros, and when you write to it, basically you destroy the whole, and sectors get allocated then. Not? And notice that not all tooling handles sparse files. One of the tools is, for example, SCP. So if you SCP a file, it allocates also the holes, basically, and sparseness is gone. And some other tools require that you explicitly specify that you want to use or keep the sparseness. For example, with tar and the rsync. And underneath, there are multiple implementations, how that is handled in Linux. There are two I/O controls to find mapped and unmapped areas. There is the old FIB map, but that requires root privilege, so it's not too well suited, depending on what you want to do. Then there is the newer FIE map, and there is also lseek, has the events argument. You can use seek whole or seek data. That's how you can basically position in the file to the next whole or the next mapped area of a file. There is also fallocate. There you can do an fallocate fl punch hole, and that basically allows unmapping area in the file. But one thing you have to also know is not all file systems support all of these variants, or even one of the variants. There are file systems that basically don't have a concept of sparse files. So if you copy a file onto such a file system, the whole sparseness is also gone, and even the holes are basically occupying space, and it really writes every zero and everything there. That's basically the real world. So depending on some tooling, you have to be really careful. Ddrescue, that is basically when you use it to read stuff. I recommend using that because if you ever have some problems, errors, then that helps because it automatically does the right thing and reads all the blocks that are still good, and then it also has you have a log file and you can do further passes on it. And don't use DD because I think you saw that. Very good. Time is up. Don't know any questions so far?
We don't have time.
And the live demo, we skip that. But basically that is the live demo, not. Thank you very much.